Okay, sorry about that. That's a long video. Anyway, it's the same. It's a proportionality. So I need a known at 50 degrees. Um, so at 50 degrees, I'm going to flip this over, KCl, 50 degrees, 50 degrees, KCl, that's 40 grams. So 40 will go into 100 grams of water, and I think you already see what the proportionality is. But yeah, if you need to solve this, then solve it how you want, but I'm telling you it's 200 grams of water. Proportionalities, again, it's just like this. If I double this, then I double this. If I double this, then I double this. I mean, 2 out of 10 is equal to 4 out of 20, right? Okay, at 40 degrees Celsius, how much potassium nitrate can be dissolved in 300 grams of water? Again, this is kind of trivial. Potassium nitrate is KNO3. The temperature is 40 degrees. 40 degrees, KNO3, 60 grams. Now, if 60 grams will go into 100 grams of water, what do you think will go into 300 grams of water? How about 3 times that? How about 180 grams? I mean, these are simple proportionalities. They don't require much thought. If this is 3 times bigger than this, then this has to be 3 times bigger than that, period. How many grams of NH4Cl will be needed to saturate 200 grams of water at 70 degrees? Again, I could set up a proportionality, but why? I mean, I can just look at the chart and double it, right? 70 degrees NH4Cl. NH4Cl, 70 degrees is 60 grams. I'm going to go ahead and do it. Oh. You know, a year and a half I've lived in this room. A year and a half. And it never was the case that I had a stupid timer on my lights. Anyway. So what did I say? Oh, I've completely forgotten. NH4Cl at 70 degrees. NH4Cl, 70 degrees, 60 grams. So let's just do it. 60 grams over 100 equals X over 200. Now I could do 60 times 200 and then divide it by 100. Let's just do that. Do you want to cross multiply? You want to solve for X. So I was solving for X, I'd do 60 divided by 100, enter, times 200, enter. Hey, look, double the amount, 120 grams. Shocker, 180 grams. Grams H2O. I'm sorry about my units. I get a little lazy when it's late here in the after hours of the chemistry room here. What time is it? 5 o'clock. Holy crap, I've been here a long time. Sorry about that. If you think crap is a curse word, then I apologize. Will sodium nitrate be saturated, unsaturated, or supersaturated if 60 grams are placed in 100 grams of water at 40 degrees Celsius? So 40 degrees, 60 grams, NaNO3. 40 degrees, 60 grams, NaNO3. So it's below the line, so it is unsaturated. Unsaturated. An unsaturated solution of potassium chloride at 80 degrees has 20 grams of solute dissolved in 100 grams of water. How many more grams of solute must be added to saturate the solution? Well, I need to know what it'll hold at 80 degrees. They also didn't tell us how many grams of, oh yeah, they did. 100 grams of water. Perfect. So in 100 grams of water at 80 degrees, and they've added 20 grams of KCl. So let's see how much can go in. 80 degrees KCl. 80 degrees KCl. So it'll hold 50 grams. That's how much saturated is. Saturated is at 50 grams. And they've added 20 grams already. So an unsaturated solution has 20 grams of solute. So if I have 20 in there already and I can hold 50 to be saturated, then 50 minus 20 equals 30 grams of KCl. That's how much I can add before the solution is saturated. Name a compound that shows a decrease in solubility from 0 to 100 degrees, NH3. Why is this? Because it's a gas. I think this is well-traveled ground, right? It's a gas. Oh, by the way, the longer-winded I am, the more video I make you watch when you're just writing down answers to get that grade. Okay. Explain why a soda goes flat when it is left open for hours. Use complete sentences. I refuse. We've described what happens with the solubility of a gas as temperature increases. Well, what happens to a soda? What happens to the temperature? We're going to put temperature of a soda over time. And as time goes by, the soda temperature goes up. So what happens to solubility of the CO2 that they've put into the soda? It goes down as the temp goes up. That's why it goes flat. I'm not going to describe it in sentences. I just use complete sentences. Yeah, you should understand that. The temperature of the Coke goes up as it's left out of the fridge and after it's opened. And as the temp goes up, the solubility of the CO2 goes down, which if you have let's say a Yeti cup. Yeti cups hold their temperature for a long time, right? So the temp doesn't go up. So does your soda go flat? Well, it goes flat very slowly. Like I have a soda somewhere around here that I've had since this morning at 6 a.m. and it's still carbonated. Why? Because the temperature's low. As long as I keep the temp low, that CO2 will stay dissolved. Makes sense, right? Yep, good. What is an electrolyte? Oh my gosh. An ionic compound is an electrolyte. And which type of compound would you add to a solution to increase conductivity? Conductivity means that electricity can move through it. Again, NaCl dissociates positive atoms, negative atoms. That makes it easier for electricity to move through all these little electrons. They love being in an electrolyte solution. So that's why. That's what increases conductivity. Describe how the compound sugar is dissolved in water. Draw and label a picture of the process of solvation or dissociation. Okay. So here we've got two D words. We've got dissociation, we've got dissolve. Dissociation is when I have a molecule. This molecule is NaCl. So here, let's draw it the right way. We have NaCl, and they are connected, right? And when I drop them into water, this bond breaks, and they become their positive and negative selves, right? So the molecule itself breaks apart. Now, let's look at sugar, C12H22O11. And this is a molecule, right? And this is another molecule, C12H22O11. And so on and so on. And so I'm going to pretend that each one of these is a molecule of sugar, right? This is all sugar. Well, dissociation is when the atoms fall apart from the molecule. That is not what happens when things dissolve. This is sugar. It doesn't fall into its carbons and hydrogens and oxygens, and you don't just have a water full of carbons and hydrogens and oxygens. What happens is the molecules separate from each other. That's what dissolved means. But they stay whole molecules. So if I look, I'll find a whole sugar molecule, all of this still connected. And it will have separated from the other molecules, so it will dissolve in water. You won't be able to see it anymore, but it doesn't fall into its ionic parts. Whereas things that dissociate fall into their ionic compounds. They fall into their ionic atoms, right? Okay. Describe how the compound NaCl is dissolved in water. It does not dissolve in water. It dissociates in water. Draw and label a picture of the process of solvation and or dissociation. I've already done it twice, so I'm not drawing any more pictures. This seems kind of redundant here. That's what dissociation looks like. That's what dissolving looks like. Would a covalent or ionic compound create more solute in a solution at the same molarity? Well, let's think about that. If this is 2 molecules, it will fall into exactly 2 parts. If I have, let's say, an ionic compound of MgCl2, this will fall into a magnesium atom, 2 chlorine atoms. So even 1 mole of this will fall into 3 parts. 1 mole of this will still remain 1 part, or at least 1 molecule of it. So, an ionic compound will create more solute in a solution at the same molarity. And even ionic compounds, so let's see, I have MgCl2 and I have NaCl. This one will break into 2. It'll break into its positive sodium and its negative chlorine. This will break into 3, its positive and negative. So even at 1 molar, this would create more solute than this. It's just more particles. It's just concentration is just a measure of the number of particles you have, basically. Does that make? Oh yeah. See, I said it again. You need to slap me upside the head. That comes from Miss Irwin, by the way. That's a bad habit that she instilled in me. Now I'm always saying, does that make sense? Oh, but it is nice. Okay. Page 5, what do we got? We got 12 minutes in this video. I'm going to start a new video. We're going to make a run at this last page, and then we're going to be done, right? Right.